My name still remains Awodeyi Israel. This is Isaac Humanitarian Foundation channel. So we're still going to be looking at organic evolution under biology. So let us start with organic evolution. Now, the introduction, that's the definition of evolution. Now, what is evolution? And when we talk about organic evolution, we're talking about evolution involving organisms. So when you hear the word organic, means organisms. So what is organic evolution? It is the gradual changes. It is the gradual changes that occur in an organism, or you can say take place in an organism over a long period of time, leading to changes in the structure and function of the living organism. So when we look at organic evolution, we're looking at the gradual changes that occur in an organism over a long period of time, and what happens afterwards is that there's a change in their structure and also in their function. So that is what we talk about evolution. Evolution is very, very important because most times there's two beliefs. There's a belief of the creation and there's a belief of evolution. But I believe that we should make them together because evolution can take place, or it has taken place at every time. This earth was not the same 6,000 years ago. So we're going to go to the theory of evolution. The theories of evolution. Now we have Lamarck's theory, and we have Charles Darwin's theory. Now, before we start these theories of evolution, first let's look at evidence before we go back to the theories. Now, this evidence, they are what help us to understand what evolution is all about. They indirectly point out to the fact that this world was not the same 6,000 or million years ago. And one of them is fossil records. Now, these are remains of dead organisms that are cemented in sedimentary rock over a long period of time. We also have biochemical similarities. We have comparative anatomy. We have fossil records. We have embryology. We have embryology. Okay, we have biochemical similarities, comparative anatomy, and biology. Now, in talking about biochemical similarities, there are some chemicals in the body. When we talk about biochemical, means chemicals in the body that is found in the living organisms. Now there are some that are specific for a kind of organism. So when they see a trend in that, they can actually determine how evolution has occurred. Now, comparative anatomy, we are talking about the structure of, in terms of the height, in terms of the shape of the organisms. So when you compare, especially looking at vertebrates, now there is an evolution that occurs in the vertebrates. Now, starting from the first, we have the spices. After the spices, we have the amphibians. Afterwards, we have the reptiles. Afterwards, we have apes. Then we move to mammals. Now, there are some changes that occur in these vertebrates. So, like the spices now, they are found majorly in the aquatic habitat. So, there is an evolution that occur based on research that amphibians may likely be evolving from the species or the spices, because they still live in an aquatic region. They are amphibians. That's the word amphi means they can stay in two places. They are found in land, they are found on land and water. That's why they are developmental stage. Part of their developmental stage, they are found in water, aquatic regions, and while their adult stage, they are found on land. So while the reptiles, study still shows that amphibians evolved from reptiles, and that's why they are the first successful land colonizers that are able to survive on land, based on the fact that they have skills so that they're able to conserve water. And now we have apes. Now you know that scales are also found on apes on their legs. So they believe, or based on research, it's been proven that, though indirectly, that apes are evolved from reptiles, but though they have the ability to flight ability. The same thing also with mammals. Mammals, there are some specific apes, though they are still extinct, that they were able to give birth to young ones alive, because all these organisms here, they are egg producers. And while this one, that's what we call oviparous. Now, oviparous means egg laying. Viviparous means to give birth to young ones alive. Now, mammals also have distinct features as well. They have the presence of hair, skin, the mammary gland as well, also make them distinct, and that also so this is evolution. So that is on comparative anatomy. Now, embryology also helps that to prove that vertebrates have a common ancestry. Now, the word embryology comes from the word embryo. Now, doing a scan for these vertebrates like spices, the amphibians, the reptiles, the apes, that's the birds, and mammals, they say that there is similarities in the embryos. They have the eye, they have the tail as well, and also it shows that evolution has occurred over a long period of time. These are indirect evidence. Now, I said the word indirect. They don't really prove directly that evolution has occurred, but indirectly, it's showing, it's just giving a gap. There's still, though it's still yet to be concrete, but it's still showing that evolution has occurred, that some organisms have changed over a long period of time. Now, let's go back to theories of evolution. Now, looking at Lamarck's theory, Lamarck can be regarded as the father of evolution because he first postulated his own theory, and he talked about the use and disuse of body organs. And also he talks about the transfer or the transmission or acquired, let me use the word acquired characteristics can be transferred from one generation to another. Now, Lama's story is stated two major points. He said he talked about the use and disuse of body parts or body organs, and he talked about acquiring characteristics that can be transferred from one generation to another. Now, he was right about this because he used the story of a giraffe that is browsing on a tall tree. So over time, the giraffe had a short neck. So over time, they had a long neck because of the fact that they were browsing tall trees. So that elongated their neck. So you can also bring it back to us as well as humans. Now, you can go to the gym and start enlarging your body part. That's your arms, your biceps, you understand? And before you know it, you see that you're having parts and all things. So he was really talking about the use and disuse of body parts. So as time goes by, you see that you are evolving, your body shapes and size starts changing. So he was correct about that. But the fallacy was that your acquired characteristics. Now, acquired characteristics is what is gotten from the environment, what you do, and it's not registered in the genes, the inherited characteristics. So he said that acquired characteristics can be transferred from one generation to another, and that's wrong. Acquired characteristics cannot be transferred from one generation to another. One generation to another. So Charles Darwin now postulated his own theory, which is one of the best theory ever. That's the theory of the survivor of the fittest. The survivor of the fittest. Now, it says, it talked about natural selection. Now, it said natural selection helps to determine evolution. That is the environment impact that affects the organism. Now, the environment have an impact on the organism. So the organism that reproduce more have the ability to survive. So the survival of the fittest, imagine, take for instance, that's jam restoration now. We have universities with limited space of 8,000 spaces for students that they want to admit, and we have millions of people that are writing jam. Now it's the survival of the fittest. Now the school set the exams for the students. Now the students that does their own work well by reading, paying attention in class, doing past questions, they have acquired certain skills and certain abilities or certain let me say survival kits that helps them to enter into the university by passing their WAEC, passing their JAM, passing their POST-UTME. Now it's the exams set by the school that determines who will enter or who will gain admission into the school. So it's the nature, or it's nature has a way of selecting organism. Now the organism has a place or a part to play. Now if they reproduce more organism, reproduction That means in terms of producing more offspring, they have a way of surviving. Now, the ones that have better survival kits as well have a way of surviving. Now, let me explain this. The more the offspring, the more the chances of survival. There are some organisms that they don't produce more. Now, as time goes by, maybe because of disease outbreak and some natural causes as well, they tend to die off completely and leading to extinction. Or not only that, there might be changes in the environment as well, in terms of maybe fire outbreak, also volcanoes as well. So there are some, or maybe the habitat has been changed. So what happens is that they change their environment or they change their characteristics and they try to survive in the environment. Just like lungfish. Now there's a fish that has lungs. Now, possibly because of drying of water, these fish have a lung so that they can be able to survive more or be able to survive longer on land. And that is actually really abnormal, because fish normally supposed to have gills so that they can be able to survive in water, but this has lungs. So there is a changes. Now, bringing back to the definition, this is the gradual change that occur in an organism over a long period of time. So these are the things that happen in evolution. Now let's look at finally evolutionary trend in organism. Evolutionary trend in organism. Evolutionary trend in organism. We start with plants. Now, starting from the list, we look at talophytes or talophyta. Then moving to talophyta algae, move to bryophytes. Then after bryophytes, now these are land plant, aquatic plant, that's liverworts or mosses. Then we'll move to pteridophytes. And afterwards we move to spermatophytes. Then under spermatophytes, we can move to angiosperms and gymnosperms. So there is an evolutionary trend, because these are aquatic plants, talophytes. Then this one are the first land plants, but they still depend on water for survival. Then this is a true land plant. Then we now move to spermatophytes that have the ability to produce seed. Now, let's look at vertebrate animals. We've looked at it before. We said Pisces. Then we move to, afterwards we look at amphibians. So you can see there's a trend moving. Afterwards we move to reptiles. Afterwards we move to apes. Then we move to mammals. Then the last one we look at is invertebrates. Animals. They'll move from porifera to colenterate. And after colenterate we have platyhelminthes. We have, after we have nematodes. And after nematodes, we have Annelida. After Annelida, we have Mollusca, Insecta, so if Insecta is not the phylum, is Arthropoda that is the phylum, and so it's starting from Arthropoda, then Mollusca, then Echinodermata. So, and looking at this, you can see the trend: Poifera, Colenterate, Platyhelminthes, nematodes, Annelida, Arthropoda, Mollusca, Echinodermata. Why for vertebrates, this is the trend in evolution, and this is what we'll talk about in evolution. So do well to subscribe, click the like button, and watch other videos related to these courses as well. That's chemistry, physics, and maths for a science student. Thank you very much.